Thank you.
Good morning, all. Myself Sachin Agarwal from ISRI India. On behalf of ISRI India, I welcome you all to this webinar on importance of GeoWater Hub for effective water resource management. Let me introduce today's speaker for this webinar. We have Mr. Vishal Anand. He's a Senior Vice President from ISRI India. Mr. Krishna Rao, he's Head of Pre-Sales. Dr. Saiju Krishnan from Pre-Sales team. We also have a special guest speaker from West Bengal Water Source Department, Mr. Saurav Das. Mr. Das is a postgraduate in geoinformatics and managing the West Bengal State Water Voris portal. With this quick introduction, now I'd request Mr. Vishal to set the context for this webinar. Over to you, sir.
Good morning, everyone. I hope I'm audible, and thank you, Sachin, for the introduction. So let me start by welcoming all of you for this, I'll say, very important topic for a webinar, which is basically creating a GeoWater hub for effective water resource management. And before I get into the plan for the day, we all know how important water is, has been, and will be. It comes not only as a natural resource, but also as a very, very precious element for all of us, because water is life. That's what we say. GIS is not new to water. Water sector is one of the, I'll say, very old sector where GIS seeped in way back, I'll say, not less than 2 decades old. We said defense is a sector, forest is a sector where GIS started, entering into and try to create mapping of the sector. Water is one of them. And most of you in the webinar would know, it all started with our ArcGIS desktop and lot of projects. If I can name a few of them, like hydrology project came way back in late 90s. Then water sector reform projects happened in state of Uttar Pradesh, Maharashtra, Madhya Pradesh. And then we have projects like dam rehabilitation coming in. Then HP became HP 1, 2, and National Hydrology Project. And then we get into Voris kind of a thing where we started creating DSS. So the way our ask for water resource management keep getting changed. I mean, even GIS is also, I'll say, intelligently changing the way water is managed. You all remember we used to use a lot of ArcGIS for initially for mapping of our surface water, groundwater areas, flood management. Aquifer happened with a lot of center groundwater departments, groundwater estimation, and a lot of things we did initial days while ArcGIS desktop used to map and started creating databases for our own agencies, for our own needs, and for our own sector. Then slowly we got a need of mapping is fine, but can we do a lot of analytics? We had this problem of flooding somewhere and otherwise. So can we do some kind of analytics? So desktop gave you a lot of tools where we can do a lot of geoanalytics and spatial analysis and 3D analysis and stuff like that. So when we kind of did a lot of analysis, when we were entering into level of creating some web portals and WebGIS, the concept of WebGIS came in. And all the, I'll say, water agencies wanted to share their data. Okay, whatever they have done in terms of mapping, at least can they share inter-department, if not intra-department? So the concept of WebGIS seeped in, and we started creating a lot of portal technologies. But the way ArcGIS is growing and the way demand of effective water resource management is growing, what we have seen is today we want to not only do the data capture, because that is a foundation data management ask. We want to do the data capture. We want to do a lot of analysis. We want to do a lot of sharing. We also want to collaborate. It's not that sharing one way. We want to take a lot of data from other agencies. It's not water related, but foundation data set. Maybe we want to take data from National Mapping Agency, like Survey of India, like Geological Survey of India, like Census. Create our base and foundation data layers, and then put our data on top of it and see and do a lot of what if analysis and where it is going. And we also want to capture with a lot of new technologies. We want to use drone. We want to use, SCADA system, rain gauges, telemetry, sensors. So sensors have changed. And the similar way, computing is change. So I want to start with the concept of, from capture to collaborate. That's what ArcGIS is talking about these days, and my team will take you through the nitty-gritties of what is this. So we want to capture data with a lot of new technologies coming in. Mapping is fine, but can we use drone? Can we use ArcGIS field maps? Can we take data from all sensors? So that is what the capture tools will help you. Then once we capture, we want to really catalog it. We want to make sure the data comes in a right database format. We want to create into a right data model, because we all know if we have data model, we have right standards. And if we have right standards, we can build a lot of workflows. Otherwise, we will not even understand where our projects and use cases are going. So to take care of those models and standards and workflows, we can catalog our data with a lot of tools. Once we did that effectively, we can consume it. Consume it like we want to create some decision support system. We want to consume data from a lot of other agencies, and we want to create things like Varis. Varis, I keep coming with this right example because this is one portal which Government of India has created. It started with NRSC and ISRO initially, and then Certain Water Commission, and now with NWIC in its refined form. It's basically a huge memo system of decision support system where we can working with a lot of indicators on water management at a national level. And once we're able to consume this, can we collaborate? Ultimately, why we are doing this? We are doing this basically so that we can, improve the management, we can improve the resources, and make sure ultimately it's for community. Can we include community in it? Can we share with others? Can we take data from other? Are my portals or my use cases interoperable? What I'm trying to do with flood management, it is talking to Mike. Is Mike data coming to my data? All this is possible and see a common operating picture when we collaborate. So this is a concept of, I'll say, a geo water hub, where we talk of capture, catalog, consume, and collaborate. And without taking much time, my team would introduce these concepts to you, that how a water hub can take care of and take advantages of these notions or pillars, and come out with a beautiful examples of developing some Varis, not only for center, but also a lot of state department. So with this, I will leave this to the team, and I wish you have a great deliberation today in the seminar, and all of you take some nice inputs, where the technology is going and how it can be effectively used for water. Thank you so much, and all the best.
Thank you, sir. Thank you for setting the context. And now I would like to invite Krishna to present that further story on this. Varis.
Thank you, Vishal and Sachin. And I think Vishal has set up a very excellent context for the entire session. And I would like to just take you, he added all the projects, I will not repeat that, but in the context when it comes to NHP, which is the National Hydrology Project, a complete framework has been set up. And many of you know, this is an extension to the HP1 and HP2 projects, which you have been working on. So when you look into that, there was quite of a standardization of things which have come in. They come up with a very common framework agreement, which is coming there. And it also included your flood forecasting, inundation system, also the river bank assessment and planning, both for surface water and groundwater systems. And another very good point was, they also agreed for a capacity building among all the water agencies. So having this background of this and what Vishal has already mentioned it, I would like to take you to a presentation of how we are enabling it from a technology perspective, how we are doing it. So let's go through our session. I hope you sorry, I hope I am audible now. So when you see our RGS system is providing you three fundamental focus areas. So one is definitely the system of engagement, where we are providing and facilitating you with various apps and tools for creating your data sets. And once we are engaged with that thoroughly, that is where we are creating with system of records. So what you do, what are all the data curation and all what you do, then you store all of that into databases, and then as you know, Vishal was mentioning about taking on to portal and enterprise, where you're trying to share all the information, which is again a very key component of this particular entire project. How you disseminate and how you share your data through services so that various departments can consume or various users can consume them either through a web application or through a mobile or through any other applications for deriving and water level analysis. And finally, we are also providing you with a lots of tools, which is actually enabling you to do a lot of analytics. So here, in this case, it could be a water analytics or a geoanalytics, what we call. So that's the three frameworks under fundamental system we are setting up: the system of engagement, system of record, and system of insight. How are we doing that is something which I will be showing you. To enable you to start with any project, the most important thing is you need to have your base data. And I know many organizations are spending a lot of time of theirs in setting up these kind of base layers. We are glad we understood your issues, we understood your problem, and through our Living Atlas, we are providing you all the base layers which are required essentially for your work. So you can take in all this geographic information from us. We provide them in form of services, and these services can be consumed in your application and or your desktop apps, and you can start working on it so that you spend a very minimal time on creating all these administrative layers for your work. And how we do that, it's a very simple thing. In Living Atlas, you can go and search. I mentioned the URL down here where you can go and search for this. So for example, I've given you for some of the glacier or water bodies for a Himalayan region. So you automatically get those URLs, you can add it up, or you want to see in this, you can do it. So that's how the simple is. And it has a host number of layers. And we have very India specific curated data, which is being hosted out. You should use this data to take benefit and save time for that. And then once you have this data, you come into our most powerful curating engine. We call it as ArcGIS Pro. For some of the users who would have not heard about ArcGIS Pro, ArcGIS Pro is our next generation desktop. This is completely replaced the traditional ARC maps, which you are aware of. ArcMap, ArcScreen, ArcCatalog, all have been replaced with one single app. We call it as ArcGIS Pro. The beauty of this is on the right side, you can see all the capabilities which it can do. And the other thing, when I look into water perspective, you need to bring data from multiple data sources. And that's what it helps you doing that. It has an inbuilt 2D, 3D viewing thing so that you can actually see the both 2D and 3D patterns together in the same view. And it also enables you to bring in the 4D data, which will actually help you doing identifying various patterns and making predictions for the project which you are doing in. And as this is all about dissemination, we also help you doing quickly share the projects. So one key thing is once you have all of this, what happens when you get a data, sometimes you feel that your data is not correct and there are many missing aspects to it. So that's where we are bringing these data engineering tools for you, which is your first step for your any analysis. So you all would like to, surprise what is my data, where it is missing, what is wrong, what can you add, how should you transform? And that's where my data engineering tools will be helping you do that. So this is, for example, what I'm showing you is on the right thing, you can see on the animation, you get this data engineering tool. Once you click upon that, this is gives you the state of your data health. And then you can see there are many missing data sets. So we give you a GP tool where you can find the missing values. You can find all of them. You can highlight them. So now you can see here on the barometric where you have those missing tools which are coming in. And then it enables and adds a new fields and generates the value based on the provisional tool. That's how you can curate and standardize your data sets before you start doing further work on it. And once you have done, now you see, as I was telling you, you have a 2D, 3D, you create all your base layers. The base layers comes from Esri. You create your layers which are required for the stream layers. You can show a 2D, 3D about how your area looks like. And then you can also do a spatial temporal analysis. So here you see you have a lot of data which is coming in from various rainfall data for the year which you are working in for, and you can create a complete time series animation also out of that. So then I think let's first see if I have talked that, and I'll ask my colleague Saiju to show how all of these things are happening within the ArcGIS Pro environment.
Thank you, sir. Hope my screen is visible to you.
Yeah, it has come now.
Yeah, Thank you. Thank you. As mentioned by, as given introduction by Mr. Krishna. So what we see is a desktop application, which is ArcGIS Pro, the advanced version of desktop application where from ArcMap. So as mentioned, those standalone applications which was existing earlier in ArcMap being replaced, and it is an integrated application where all these applications comes in together in one application. There is ArcGlobe, ArcScene, all these 3D, 2D, all mapping applications, standalone applications integrated into one platform, and this gives a holistic view of desktop data processing and analytics. So, having said that, I will directly stick to those contents mentioned by Mr. Krishna Rao, and as mentioned, there are many geoprocessing tools which exclusively dedicated for many activities with respect to handling spatial data. They are in the form of extensions and they are in the form of add-ons and many forms, many data tools available, geoprocessing tools available. So in specific to water, I will point out few which are in particular for water resource management and water resource activities. So specifically for groundwater activities, we have many tools like Darcy flow, Darcy velocity, which gives us groundwater balance for steady flow and calculates the groundwater balance, calculates groundwater seepage, and delineating watershed, and many hydrology tools like we have many tools like basin, generates basin out of the raster, fills the gaps, generates stream or order the stream which we generated out of the raster, and converts the stream to feature, and creates a watershed out of the elevation data that we input. So generating our basic information or basic layers or basic data that is required for any of these watershed analysis or water perspective activities can be generated instantly out of all these available inbuilt tools available within this geoprocessing toolbox. And as mentioned about engineering tools, data engineering. So I would like to mention that data engineering contains tools for analyzing analyzing the data distributions and patterns in context of both space and time. That is where we see data, where we see tools in the form of what is it called here, space-time analysis tools, which has multiple tools incorporated within which will facilitate us overcoming many tasks. Earlier, what we dealt with is our maximum extent is 3D. Now the time has changed. Now the fourth dimension has come with respect to space and time. Time has been embedded to the applications and spatial data. So with which we able to visualize and be able to bring insights of our data what we have. So having said, I'll just right away get into the demonstration. So this is one data as mentioned by Krishna Rao, where we have the spatial data of ground borewell locations, which gives us the depth of water over there in the borewells distributed over there in the state of Punjab. So here what we see, rightly what we see is the spatial engineering tools which gives us the statistics of what is being missing, where is being, which are values being missing, and all display our data will be displayed and will be highlighted for us, from which we able to see that there are few fields where data are missing. So this is from the field, on the field these null values are missing from the bore locations. As we see, there are few fields missing. So how to overcome this? It is either we have to go to field and go to check the data from the field and fill it manually, or otherwise we will find spatial analytics over it, and according to space and time we fill according to many methods like averaging, mean, many methods like by default tool which will run for filling these values will be like as I mentioned to you before, there are space-time pattern analysis tools. We fill that values based on tools like fill missing values. So it functions on the method like as I mentioned before, like based on minimum, average, median, maximum, temporal trend, based on the neighbors. So it is like having said there are default methodologies adopted in filling that. It's not directly will fill with some random values. So we have fixed distance, nearest neighbor, contiguity to edges only, and spatial weightage from file. There are many methods which is appropriate to fill any of these missing fields with respect to the type of data we deal with. So having said, applying this tool, we will able to fill these missing values in the upcoming fields. Like we have many fields appended to this, have providing this methodology applied to fill these fields. So in the form of standard deviation and many other forms, many other statistical forms, these fields will be updated. As we see, only those null values fields will be updated for all these databases. So this is how a data engineering tool works with respect to fine tuning or curating the data in desktop application, which is of which needs to be understood initially. And next is the space-time tools. As I mentioned, it's space-time tools. You can see the pattern of time series analysis, where we have generated the same borehole data being generated for time series analysis, and it is space-time cube, where data is displayed in the form of 3D. Give me a second, it's just so as we see, data is plotted on a three-dimensional view in the 3D scene. As I mentioned earlier, it is integrated application. We have 3D scene application where time series plotted off are those borehole data along with the time has been generated out of it. So next to that, I will also update you. I will also like to demonstrate you something else, which is scientific application of scientific concepts in deriving certain outputs out of the available data. So here what we have is data for a watershed where we have stream order and the contours. So scientifically stated that where intersection of contours and streams, where there is a possibility of constructing a check dam. So it is directly being applying one tool, geoprocessing tool. We derive those locations having intersections of contours and streams with respect to stream order. So we generated locations of check dams out of it. So these are all check dams distributed over there in the intersections. Proposed check dams, suitable locations on field. So as mentioned earlier, these application is also capable of handling 2D and 3D parallelly. We have 3D application and 2D application brought in together over here. 3D scene view, and this application is also capable of working parallelly with both 2D and 3D. So if we align 2D and 3D in a one window, it will help us working with this data parallelly. It interacts each other. Both the windows interact each other in handling the spatial data in 2D and 3D form. So thank you, sir. I hand over the session to Krishna.
Thanks, Saiju. So you have seen what Saiju has shown about those capabilities. I would like to also show you one of a very interesting feature about, we have introduced a new concept with this power of ArcGIS Pro, which has come in. We are able to do many things, how to validate your drainage network, what you have built, which is very important for your workflow. So we have introduced a tool called, trace networks, where you can check about how this data is going to work in. So let me do probably a trace maybe from these 2 points and see how this entire work will be doing. And I'll run a downstream trace of this particular aspect, and you'll see how it actually traces this. So now you see how intelligently this has actually traced this diagram. And now within your thing of the network, which you are seeing in how the interconnected nodes and flow is going. So this will help you in doing a very good planning. Maybe it's a micro watershed level or any of those things. So this is the benefit when you come into ArcGIS Pro, where you can take advantages of these kind of tools and validate your drainage networks of the kind of quality work which you can do in. So that is what I thought of share that for you. And let me go back to my presentation, where I will be showcasing you about where I left it out. So next to that is there are many needs. Another very important need for you is, you need to see what are your different water spread area of the tanks or the lakes which you are managing. And you want to do it for a period of time, maybe for 5 years, 10 years, or maybe for a week or for a month. And then, so if you have to do what is a water extent area, it's manually, it is something which is very impossible, right? And that's where my power of automating these solutions, making use of your Landsat, Sentinel library, and other satellite library, you can take advantage of our hosted images layer where we can do almost automatic thing and we can provide you all those things. So how we are doing is we have different kinds of viewers and we have different kinds of data layers which you can see in there. And you need not have to this where there are a lot of issue when you're doing for data rendering and generating. So what is your pain point if I look in? You're searching and downloading images, then again storaging issue, a lot of investment in image processing thing. So we understood your thing. So how we do it? We bring in the Mosaic data configuration scripts. We have written all of those tools for you. And this can bring data from your open data sets which are available on the AWS profile. So you can see Sentinel-2, RadarSat, Maxar open data programs and other things which are there which can be run. And you can use it not only for water, but all associated. Maybe you're looking for agriculture and water being so closely related. Your disaster and droughts, all those are related, where you will be requiring these kind of things which are required. So what's the advantages to you? You need not to download any images, make any changes. You can subscribe to my service and we give you this at a cost. And once we do it, what is happening actually in the backend, you see, we are using this Landsat pre-trained model. We are converting them, bringing them into this, and then you can see over the period of time how the water extent would have changed over the period. So you can see from 2013 to 15 and over the changes, you can see this was done for a small area within the Andhra Pradesh, where you can see in here, and you see the water extent from 2013 to 21, the water level has increased. And that is how, this is what is the workflow for delineating them. So how we have done this is we have used the same tool for MDCS, and you can see now I have extracted the water bodies for the over the period. So what I have done, I have taken here for 2020 from March to June. What I have done, I have run this particular tool, and you can see it is brought it in volume, and it runs, everything runs on the cloud, and your output things comes into this game. So this is a subscription service which you have to hire from us, and we allow you to do all these kind of things, and you extract only the water layers. So this eliminates a lot of your headache of doing this. You get only what is required for you, and you can do it. So such kind of advanced tools have come, which is going to help you in your water projects in there. So once you have done the curating, you have done all those automations, now comes how you quickly disseminate all these things. And that is where my powerful aspects of RGS Enterprise comes. Most of you know what it is there. I'm not getting into it. Vishal again mentioned about portal being there. So this is how it is coming in. So this is one thing which we did for our customers based out of West Bengal. So this is how we have done this. You know, we created the West Bengal resource system. We have the portal homepage. We build those dashboards for data analytics. This is for water quality. Then you have a query reporting chart view of this. Then we are also integrating the real-time data which is coming in from Encordia. So that's what the West Bengal uses it. So we are brought in for the real-time RTDAS data is coming in. We built a data integration API for that. And then from there, we are brought in, we're doing insights analysis and a state level analytic dashboards and all have come in. So once these have come in, I would request, to my colleague Saiju to very quickly show a very short demo on what are those web applications. And then I will ask our customer who is already waiting for us for this particular demonstration. Saiju, if you can quickly finish the tool.
Thank you, sir. As said, thank you, Krishnan sir. As said, it is an enterprise portal where we have the portal as a view, where we have the capabilities of content management. And on the content management, we'll have all the contents which been published over here. And as mentioned by Krishna, there are multiple applications can be developed instantly and in a configurable manner with the motto of low code, no code or low code. So with this application and the data being applied over, analyzed and curated in the desktop, we create applications as specifically there are web applications that can be created out of those data that we had analyzed in the desktop. And this is the same data that you are seeing in the desktop, out of for which we have created an application, web application. For simply, I'll run a tool where if you wanted to further analysis on finding nearby locations of any assets on any nearby location. So At a distance, you specify the distance, at what distance, how many number of assets you wanted to identify, which will give you the number of drainage, what are the drainage lines, and number of check dams in association in neighboring to this particular location. So this is how an online analytics or online querying can be carried out with respect to the available application. Configuring inbuilt widgets available comes along with these applications. And there are multiple other applications where you can do further more analysis on having incorporating many data in the form of many data layers with respect to very small scale to larger scale. What you are seeing is a large scale of one micro watershed, and what you see is a small scale of a national scenario where you upload all the data with respect to water sample collection management. The sample collection can be managed over here, understanding what is the status of sample being collected, querying with respect to administrative with respect to administrative unit, and along with space, date, and time. To the larger scale, to the minor scale, we drop down and we scale down into to the largest extent to define the date. You can define the date according to the year that you wish to, the number, as the data is collected, we define the date. Let us empty it. So to this date, how the data been varying, how the data is collected, and the type of information, querying the type of information, whether it is bore well, whether it is from the canal, or it is from the drain, or it's from the hand pump, or these kind of data sample collection management can be carried out with by having applications which dynamically interact with the spatial data that we intended to perform activity on field. And we have another application which having data being collected from field have brought into the enterprise solution in the form of services. We have further analytical capability in the form of models can be generated out of it, and these data can be consumed by various other stakeholder departments or sister departments like health department or population census department, or many departments. Here I have applied these same value, groundwater value being collected from the field, applied in a model to generate relating population and health data out of a number. Let us assume weightage for all parameters in parallel, just for sake of deriving the output. So we derive spatial outputs in this fashion, relating all the spatial data collected from field. So influence of fluoride over the population in an area, in that selected area of interest. Thank you, sir. Over to you.
Thank you, sir. So let's go back to our session of this. So once you have seen how we are able to do curation of data, validation of all those data, now we are able to build some intelligent web applications, and now comes for a real-time field validation. How is that going to happen? And that is where our enterprise solutions bring in our host of mobile GIS solutions. So we have a mobile apps, which we call it as RGS Field Maps, which gives you a geocentric application experience. So basically, when I say geocentric, it is map focused. So you can take your data onto your mobile device, you can connect to the service, and you can do a real-time update. You are going, since these water bodies may be in some areas where you may not have a good mobile connectivity, then you can use this for your offline experience. You work on your ground, collect all the information, take your data offline, ghost, use field maps, collect and update the information. And then once you are connected to the network, you can update it. Similarly, associated with that, you may also sometimes require to take a survey for the surrounding villages. But it could be any reason, maybe the economic dependence of the villagers on these particular water bodies. Or it could be a survey for probably rehabilitation, which you would like to do it. In such case, you would like to have more of a form rather than a map being a center of your thing. So that's where we give you an app called RGS Survey 123, which is a form centric experience. And for people who want to do a very rapid capture, so you're doing very quick, you see there is a development activities done. There are a lot of bunds which have been built, or water holding structures which have been built, or a watershed has been maintained in there. You want to take a quick picture on the go on your vehicle, use our quick capture. So these are the three varieties of, essential apps which can actually help you do that. But if you have a large amount of your workforce also on the ground, you can use our RGS workforce and also a navigator which can actually give you directions. With these different 6 different apps which you're seeing in, you can choose, pick, and you can do that. And my RGS Enterprise enables you. The beauty is you need to just have your RGS Enterprise or online licenses with you. Download these apps, native apps onto your mobile, connect to your enterprise, and start.
Krishna sir, you're not audible. Having said that, let me take the session. I mean, I'll just would like to demonstrate the mobile application with respect to what Krishna is mentioning. Can you pass on the slides to me? Yeah, thank you. So as mentioned, we have multiple mobile applications being under our Play3 enterprise solution, which as mentioned by Krishna, there are survey 123 applications, field maps, which are all specific application designs in terms of convenience of the user, how he needs intent to collect the data. Let us say survey 123 is a form centric application where a user needs to devise a form as in the form of, as we develop a questionnaire for the researchers well aware of this is a technology. I'm well aware of the system or device in the questionnaire. Same questionnaire can be bought in a digital form and take into the field, and that can be configured in the mobile application, take to the field, fill the information along with the important aspect is along with the coordinates, and the geotagged photographs from the field can be uploaded into these survey forms, these kind of survey forms. So these kind of survey forms can be instantly created and configured, and a mobile application can be created. The other application is the mark centric application, which is survey 123 application. Field apps which consume services from the enterprise portal solution, and that service will consume the data from the field, and the data will be directly updated on the central database or the service that we consume to create the collect the data from field. So having said that, let me show you, this is the same application that you're seeing in the desktop and in the enterprise solution and the web app as well. So which is being configured in the desktop, dashboard, which gives you a simple statistics of number of check dams proposed in the watershed and the number of check dams verified from the field. So these are the two numbers available with us, which is like 118 and 58. I just deleted the test point created earlier. So let me also try to recapture point from the field or verify these points from the field, from the watershed on field. So what you see is the mobile application. So these are the mobile application I was mentioning. Field Maps is a one mobile application which consumes the service directly. So we edit the service from the field, directly from the field. So since I'm in Bangalore, I'm taken to my real-time location. So this is the watershed region where we have created some check dams out of scientific methodology adopted. So all these scientific or automated technology may not be having 100% result as on the real ground or the reality from the field scenario. So always there needs to be field verification needs to be conducted for any of the output generated just like that out of it. So let us assume this particular stream has two check dams created. So these may not be in exact position where it is being created, or there may be in field scenario it needs to be shifted to some other location. Let us assume instead of this particular location we are proposing a check dam over here. So we are creating a point. I am proposing a check dam over here, and I also can geotag the asset location from where verified, yes, remarks, new, proposed earthen check dam, contour, let us say 550 based on the measure. And let us make us test, and updating all these fields, we submit. We submit the point that we have collected from the field using the field maps application. So our intent should be, it should reflect on the same central database instantly on real time. So as we collected the point, we will able to visualize the same point on our dashboard. As we see, earlier it was 118, now it has turned to 119 with 59 verified points. I just verified those with the point which I have collected. And this is the point, locational check dam which I verified from the field and collected from field. As we see, this is the point just I collected from the field. Field attributes that is entered and the geotagged photographs from field. So this is how a mobile application can effectively be utilized in collecting data from field on real-time basis. Thank you, sir. Over to you.
Thank you. Thank you, Dr. Saiju. I would like to invite our customer, Mr. Saurav Das. He has done his MSc Geoinformatics and is having about 8 years of experience in GIS, and is currently managing the state WARIS portal at West Bengal, implemented by the State Water Investigation Directorate. And he works as a database manager to take us down with how he has utilized this technology in building the WARIS portal for the West Bengal. Over to you, Mr. Saurav.
Hello everyone. Good morning, everyone. Today I am going to explore about GIS, ArcGIS Server Enterprise Advanced. It is a full-featured mapping and analytical platform. It includes powerful GIS web service, server plus dedicated web GIS infrastructure for organizing and sharing our work in order to make maps, geographical information, and analysis available on any device, anywhere, at any time. Now I am sharing my screen. By that ArcGIS Enterprise, we can showcase your data and for the analytical purpose and any other publicly to WebGIS portal. That is our main page, West Bengal State WARIS portal. There is many application like groundwater dashboard, groundwater level dashboard, water quality dashboard, water quality analytical dashboard, and there is many I think RTDS dashboard. That is the real-time dashboard from that measuring by the sensor and send via GPRS through GPRS and automatically show in the dashboard. And last, this is the Insight Data Logger Spatial Distribution dashboard. This is the groundwater dashboard. There I can see all information at a glance, where I have 2-3 column. They MP means MP and average level, water level in that there the total. Here you can see the total number of well station here 84, and total piezometer type of well, piezometer 50, total deep to well 33, and here is many other information like location, like RL, everything. There I can click one station, then they show the only one station information at a glance. Total piezometer 1, deep to well 1, and near in the bottom of the page, year wise water level you can see, and block wise water level you can see. And another dashboard, there is the water quality dashboard, where we can see the full picture of that state scenario. There is only 3 parameters, but near about 5 to 10 parameters is present in our database, but only show is the 3 parameters. That is SP contents and bicarbonate, TDS. In the left side, you can see the station information, right? Rajgram PHE. And the depth of that 12.4, RL is 29.8. And when I select the only one station, then we see the change. What is the condense? What is the bicarbonate? What is the TDS? Everything. And this is the water quality dashboard. And at the this is the RTDS dashboard. Just open. This is the RTDS, is the real-time data. This is coming from the station where just three parameters is present: water level, temperature, pressure, and battery voltage. 4 parameters. Where there's the total number of station I can see in the 82. Total number of station 82. Total record. This is only for 4 to 5 years data. Near about 5,12,312. Where the water level is average, that's mean is first is the average water level minus 3.746, minimum water level minus 22.45, and maximum water level 9.965. Same time in temperature, there is average temperature 26.217, minimum water level 99.1, and maximum water level maximum temperature, sorry, 99.5. The same the pressure, what is the average pressure, what is minimum and maximum, we can look at a glance. And that left side, the water level trend, monthly the water level trend, how is fluctuated, that you can see at a glance. And the right side, the battery voltage, this is main important portion, because anytime battery voltage is down, then data cannot transmit to the server. That's why this is very important. And how monthly this change, my battery voltage is changed, you can see at a glance. And next and last dashboard, that is RTDS Insight dashboard. This is designed by the RTDS data, from the RTDS data, where we can see the total how many years data is available in the server, and who is station name, and all the station name is present here, and how in that database there is only 2016, 17, 18, 19, 20, 21. But in this Insight database, we can validate the data, because there is 2005, 2006, but my database is from 2016, but that is the error, the 2005 and 2006. We can or even easily determine this one, easily identify that error from that Insight dashboard. And there is total record is 5,12,311 data, and how the yearly how that is fluctuated. In that section, there is 2 spike. I think there is some error, because you can see some station yearly can send only 7,681. I think there is some different in 2020, 8,792. That is a spike. I think I can identify that which station is problem, which station send that data with error data. I can identify from this Insight dashboard. And in the monthly and yearly data, how can send, we can easily showcase your in dashboard. And record day by day, month by month, you can design that that way. And in the end, I think that is the water trend, yearly water trend. You can see from there 2006, 2008, 2010, 2012, 2014, 16, how the groundwater level is fluctuated. You can graphically show that in dashboard. That's all, everything I can say. Thank you.
Thank you very much, Mr. Saurabh. It was a very nice demonstration of the portal. And then you can see this is now, which is what is coming in from a very working example of West Bengal of how they have used it. So he has shown us the Artidas dashboard, and I was talking to you earlier also. So let me just slightly brief you upon like what the technology which went behind in enabling all this. So I'll just take another 2 minutes for this. So, and this is where the technology which comes in from our system is the real-time analytics, where we integrating the sensor network. So all of these things are coming from a host of IoT devices which are being used in there. They are providing and feeding in this data to us. So when the data comes from these sensors, gets into our GeoEnt server, and there, and since the data comes at such a huge volume, this data becomes a big data now, where you can use our geoanalytics tool to really find out some kind of a variance or some kind of from variance or differences which you find within the data. And that's how it is helping you in doing situation awareness, analytics, and alerting for all the work which you are doing in. And this is how the entire ingestion of GeoEnt happens in. We support various out-of-box plugins where you can receive the data. There is a host of other EC2 gallery from which we're on ports where you can read this information. And once you get it, there are a lot of other out-of-box tools from where you can straight away dump it down. So in this case, this is how it happens to IoT sensor. To filter, we give you conditions to this. If that is fine, you can give a display or alert it. Suppose this is falling outside some other zones, or you can come to a change zone detection, and finally you can display those alerts onto your system. And how we have done this, so what is happening in case of Encardio, here, there is a geographically spread sensor networks, which are more than 500. And every 6 hours, one updated info comes in form of a CSV file. So if you say per day, it is about 4 updates per sensor. So in total, about 2000 CSV files which are coming per state. And this sensor network is ever increasing. Based on, they have started this as a pilot where they tested all this thing. So this sensor network is going to increase as we are going to go about. So in this sessions, what we did, we wrote a very small automation path of Encardio of how we are bringing in. We wrote this particular application, and that is what the data which you are able to see, what he has demonstrated. And this is what the demonstration, he did it under that part, and then that is how it was demonstrated. So I would like to thank you all for listening to us patiently. And thank you to our other speakers, Shaurav, to Mr. Saurav and Saizu for helping me out in this particular session. Thank you very much. And if you have any questions, we can take it.
I can see on.
Right. Okay. Thank you. Right. Thank you, Krishna, Dr. Saijo, and Saurabh, Mr. Saurabh Das, for such an insightful presentation and demo. So I see a lot of people have requested for the recording of the webinar. Well, we will soon be sharing recording of this webinar with you to your registered email address. Also, you can visit and subscribe to ISRI India's YouTube channel as well for the recording of all our past webinars and events. Right. I can see few of the questions has already been answered by our panelists over chat. So I'll take the unanswered one. There is, just hold on. Yeah. So there is one question, which is, what is the source of the groundwater levels data used?
Yeah, so the source for the groundwater comes from the state groundwater authorities and the central groundwater authorities. They are the source for these data, and this is the authenticated. So there are other sources like few of the NGOs and other bodies also collect, but the actual source comes from the state groundwater and the central groundwater agencies. You have to reach out to them for that.
Right. Okay. Thank you, Krishna. So I see all of the other questions has been answered. Still, we have time in hand. So if any attendee wish to ask any question, you can write it on the chat window and we'll be happy to take it up.
There are questions, Vivek, you can read out.
Yeah. We have a question that what we have seen on dashboard is data already inbuilt in IndoArcGIS version.
No, this data is a dynamic data coming from respective state body agencies. IndoArcGIS is only helping you out to bring out the base layers for your creations. IndoArcGIS is not hosting any of this groundwater levels data. For some places, if the client has shared with us to share it with any public domain, we are hosting them. For few areas, you may see a groundwater data sets.
Okay, then we have another question, which is, are these data being sold?
The IndoArcGIS data comes to you as part of your license procurement. So you need not have to spend any money for that. But the state government and central government agencies, you have to reach out to them about their mode of procurement, about how they do that.
Okay, thank you, Krishna. So there is another question which is linked for all past recording. So Swati, you can go to YouTube and search for ISRI India, and then you can go to ISRI India YouTube channel. It has all the all our past recording of our webinar.
I think Vivek, there
there
are a
is
few questions.
Yeah,
which have-
yeah. So is there any plugin for runoff too?
No, as such, there is no plugin for runoff, but you can use our Arc Hydro tools, which are part of the ArcGIS Pro. You can use it with ArcGIS Pro and Spatial Analyst. You can use the ArcGIS Arc Hydro to derive it. As such, we don't have any other thing, but Arc Hydro tool sets can help you doing that.
Okay. There is one question from Mr. Joshi. Is such initiative done in Gujarat too?
Yes, Tejas Kumar. Yes, Gujarat, the groundwater body is also being state government has been approached, and they are really interested in doing that. I think we might very soon see that also coming up in Gujarat.
Okay, great. So the next question is there any dashboard application to know about groundwater level state-wise?
Yes, you can go to the Central Water Commission's CWC site. They have already published all these data sets for that, and they have various amounts of data which have been using our ArcGIS technology. The CWC site has hosted it. You can look for that.
Right. So the next question is, so what is the range in years of data present?
Typically, government bodies are interested for the last 10 years, but most of the trend, they look only for the last 5 years, how it has there. You could have seen in one of our sessions about last 5 years data, how we derived it, and we were able to show the water spread, which is present for that area. So typically it is for 10 years, and what they nearly look about is for the 5 years time period.
There is a question from I think Krishna, you are suitable to answer this, and it is, sir, please give insight on how beginners or newcomers in GIS and remote sensing sector can start such water related studies using ArcGIS Pro and other tools explained in webinar.
Aisha, if you are very new to this, one of the best thing is there are a lot of open sites or open data sets which are available within the ESRI forum. You can join and take it, or otherwise you can also, undertake a training with us where we can give you on specific on different products. So I would definitely like to advise that you should start with ArcGIS Pro, get trained on Pro. It has got about 1200 plus different tool sets. In a history of any GIS person, nobody uses all those 1200. So you start with Pro, learn some of those basics about how to use it, and then you yourself can start doing many of these works.
Okay, thank you, Krishna. So the next question is, how do we define check dams in watershed, and how do we interpret?
Sir, may I?
Yeah, please.
Sir, it is scientifically said that it is suitable locations that can be scientifically proposed is like intersection of any contours or the stream. According to stream order and the stream intersection, a check dam elevation differs from higher level to the lower. As watershed goes down, the elevation will also gradually decreases. As the elevation decreases at the intersection of contours, we can propose a check dam. But on reality, it may differ on reality. We may have to verify on field as well. It can be auto-generated, but it needs to be verified from field as well.
Right. Okay. Thank you, Shaju. So next question is, any possibilities to understand here about various attributes incorporated in IndoArcGIS?
I think Omkarji, I think believe you can reach out to us separately. You can reach out at info@esra.in, and we can probably discuss this there on that separately about various attributes and all which are available through Indo-ArcGIS.
Right. So I think most of the questions are covered. Right. So even if participant has a question, they can write to us at info@esri.in and we will be happy to answer them. Right. Over to you, Ganesh, for closure.